In today's video, we're going to look at waves using a slinky. We've got a little tag on one of the coils of the spring in the middle. I'm going to stretch it out First of all, I'm going to produce a pulse along it by moving it to one side and then back. So we saw the pulse move along the spring. We saw it reflected from the anchored end and it reflected on the opposite side. So initially it moved that way, and when it was reflected it moved this way. The next sort of thing I'm going to do is send a pulse by drawing some of the spring in and releasing it. Stretch it a little bit more. So this time, and I release it, we had a pulse moving along the wave, a compression pulse, and when I did the sideways pulse, you can see the label move to the side and back. When I did the compression pulse, it moved along and then back. And we can do a continuous sideways pulse. And if we get the timing right, we can get half a wave, or 1.5 waves, one wave, and this is a standing wave. The reflected wave is being counteracted by movement, and we get a node where there's no movement and an antinode where there's a lot of movement. We can try and do that with a longitudinal pulse. So we're getting compression standing waves as well as transverse. So that the ones that are pulsed out to the side are transverse waves. That sort, compression waves, are longitudinal waves. For technicians, I thought I'd show you our storage of slinkies. So a grapnel tray, got a block of wood, cut holes in it, fitted offcuts of gas pipe, and that stores the 12 slinkies. We have maximum class sizes of 24, so 12 is ideal, but we often just do it as a demo because it can get quite noisy with 12 of these rattling about on the bench. And I've just got some extra tape for putting little markers on the slinkies.